Hey, how's the sound, guys? Gonna get started in about 10 seconds. So today we're gonna try something a little different. As soon as I turn off this thing here. Give me a second, sorry. So I got this printer in the mail. It's rather cheap. I want to see what it can do. Might use it for a open workstation. So I thought I'd try and assemble it. I haven't even opened the box yet. So let's give this a try. So I'm just cutting the box open a little here. I might have to move it because I think there's going to be a lot of stuff in here. But essentially it's a 3D printer that's made for kids, but it might be a good starter printer as well for a lot of people that want to learn about it. So let's see what we got in the box here. So looks like there's a manual. Some stuff written in every language but English, but we have English on the other side here. So I'm gonna take some of the stuff out and see what we got. So we've got our USB cord, I guess. Looks like a series of tools and a USB. Some filament. And I guess this is the filament holder, but we'll find that out. And then the little piece that holds the filament. That's all we have there. Now we got, looks like a printer partially assembled. So let's see if we can lift this out without breaking it. Okay. And a tiny heat bed. So let me lift this out of the box. This might get kind of messy real quick. And it looks like a power supply. So let me get the box out of the way here. Okay, now that we had the box out of the way, let's see what we got for the printer here. Looks like this is the print bed, and it's got a tiny motor in there someplace. My guess is a NEMA 17, or not a NEMA 17, NEMA 11. Looks like we got a controller panel. So let's see if I can assemble it. It looks like it's kind of simple to assemble. So I'm gonna have to go through the manual real quick here. So let's orient it correctly first. Guess it's gonna be like that. That's the end stop for probably the Z-axis. And I guess we stick this other piece someplace in here. I guess that's the assembly. Just worried the motor doesn't work as smoothly as I would like, but it's got good tension. Okay. So I think there's just one thing I have to hook up, and I think that is the filament spool holder. And let's see how that works. It looks like there's two holes over here. So we just pop it in, slide it down, and tighten it. We may have to put the spool holder on first, but we'll see if there's enough room. Looks like we're gonna also have to attach something for the motor and the power supply. So let's see what this looks like. I guess you slide this in like so. And then this holds the spool if I can ever get it to lock in. There we go. And then we have our spool. So that was a lot quicker than I had anticipated. We'll see what it looks like in a second. We'll do a test print. But here's the filament. So this might be kind of interesting. I've never used this filament, but it's obviously fresh out of the package. And that's going to go up to here, I think, and feed in. So let me turn this so you can see it better. Obviously it's hard to see with everything in the way. Then I got to move the power supply over, and I got to figure out what's going on with these connections. Let's see what we got here. This probably goes over to here. It's very small. There we go. And now we got to power it. So there's a power cord that comes with it. So we'll give this a try, and I'll check on the chat in a second because I know there's going to be questions. Probably not about this. So let me bring up the chat while that's going on. Guys are awfully quiet today. So let's see what we got here. Got the power. Goes in here. And this goes into the wall. Okay, I think it's powered. Now this might connect to the computer, but I'm going to use a longer one because it's a bit away. So here's the USB. So let's see if we can see it in printer face. So I'm going to have to open up printer face. Plus there's a strange smell coming from it, but let's try the home button. Wow, only one access homes? Not sure what those buttons do. But let's connect to it via printer face because it's a little nerve-wracking not knowing what's going on here. And there's a strange smell coming from it, but I don't know what that is yet. So let's see what we got here. Let me see if I can see printer face. Okay, inside printer face, I'm going to connect to it. Obviously, I'm not connecting to anything. So let's check to see what it says for device manager, if it shows up. So I'll show you this in 2 seconds. Okay, there's the device manager. Port 12 is my guess. Let's try connecting. Okay, it looks like we're trying to connect to something. But it doesn't look too good at the moment. Or the speed's off. So I'm guessing 115/200. Okay, there we go. So it looks like it's Marlin 1.1. So let's see if we can raise the axis up here. I may have burned the heat bed moving it around, but let's advance it a little bit more. So it's a very basic printer. Let's see if we can print something with it. So the first thing I'd like to do is actually print lines, but because the lines are too big for this printer, we either have to make a file or we can try printing a cube. So I'll pull up in Firefox in a second Thingiverse so we can try and do this. So 2 seconds, let me get that set up so you can see. Okay, so here's the Thingiverse website. I'm going to click on Thingiverse. Let me make sure you can see it though. So this is the landing page. What we're going to do is we're just going to search on a cube. We'll say 20 millimeter by 20 millimeter. Might have to put a space in there. Okay, so we have a couple different cubes we can use. I like this one. So what I'm going to do is I'm going to download it. It's going to take a second. And I guess we don't like that one anymore. So let's go back and see if we can try a different one. So I guess we'll try this one. Okay, this one looks like it'll download. So next what we need to do is actually go over to the desktop again. So let me pull it up so you can see. It's going to be in the downloads folder. So I'm going to click on the download that we just got, right click, extract all. And now that's extracted, so we have an image in here that we can render. So I'm going to actually use Slicer to do this, and I'll show you how to get to it. If you go over to here and you go to, let's see, Slicer settings maybe. This might bring up Slicer, but it might take a second. So let me check on the chat while that's going on. Looks like everybody's a little quiet today. So essentially, Slicer is a way to slice up your actual source print, being your STL file. And I know a lot of people have been having issues with it, so I thought I'd talk about it a little with this. Plus, this printer is under $100, so kind of hoping it's a good deal. But obviously, I'm not reading the manual right now for the controls, so I'm using Pronterface instead. And we picked out the actual speed, but my hope is that we can probably modify this for a different type of motherboard in the future. But given the small size of everything, it might be interesting. Thanks. I'm always worried about the sound when I initially start. Apparently Slicer's taking a while to show up here, so let me move it over so you can see it. If I can grab the window. There we go. So in this case, I'm gonna take a look at some of these settings. I'm gonna change it to 0.2. In first layer, I'm gonna do 0.2. I know the printer's not CAL'd, and it's also not leveled probably. So I'm gonna have to check to see if the actual heat is on before I touch anything. So I'm just gonna leave these default. Skirt and brim I'm gonna leave alone. Support material I'm gonna leave alone even though I can generate it. So that's good. So normally there's a platter that we see here. So let me see if I can see it. So I don't see all the settings. So what I'm gonna do is close this. And I'm gonna go to my folder on my desktop because I don't think I've ever opened this particular one in print run. And Slicer's right here. And I'm gonna run the executable. I may have opened it once before because there's a test file in there. So here's the actual platter. So what I'm gonna do is I'm gonna minimize this a little so you can see. If I don't knock it out of the screen, that is. I'm gonna go into the test cube. Images is not what we want. We want files. And just pull it over to here. So now I'm gonna zoom out so I get an idea of what it looks like. So that's the platter. I think this is a 20 millimeter cube. So I'm gonna adjust the platter size real quick here, hopefully. If I can remember where it is after I readjust this again. Let's see. There might be a wizard. Let's see, there's extruder offsets. We can do nozzle diameter, which is 0.4 in this case. Now I just gotta find the actual platter size. So what I'm gonna do is I'm going to see if the wizard's here. That's not gonna help. Configuration wizard. So we're assuming Marlin because we already saw it. The actual print bed is 100 by 100. So we're set there. Nozzle's 0.4, I believe. This is based off of what I read on the website. And let's see, filament diameter is 1.75. So I'm going to click next. Normal temperature, bed temperature. If this has a bed heater, which I don't know if it does, because I don't see any wires running off it. So I don't think the bed is heated, which is perfectly fine. We can deal with that, but it's a magnetic bed, so we can lift it off. And I don't feel any electronics under here, and I don't see any running around the bottom of it. So I guess we're not going to worry about that. So let me slide this back in. So bed temperature is 0. So what I'm going to do is I'm going to just try a print here. The bed size now is the right one, so I'm going to slice this or export the G codes. Now I'm going to go back over to Pronterface. This printer is the Easy Thread. I don't know if you can see it too well. I'll bring up the screen so you can see. So I'm trying out basically a kid's printer. So essentially we're just seeing how well it works, and then I may mod it for motherboards later on. So now that we've got that set, let's go over to Pronterface for a moment. And we're going to load a file. We're going to go over to our downloads, to what we unzipped. I think it's going to be in here. So I'm going to grab the G codes and see what it looks like. So the size over here hasn't been adjusted yet, but you can do that real easy by going to settings, options, I think. And inside options, let me make the screen different so you can see it. We have the COM port already set, and so we need to set the bed size. So it's 100 by 100, and the height is probably 100, I believe. So now we're dead center in the bed. Of course, I'm rotating this too much around, but let's see if we can print it. I think it's going to turn into a real mess real quick, but let's see what happens. So it's homing all 3 axes. Let me see what the bed looks like. There's probably an offset on the bed, so let me move it so you can see what I'm doing. So right now I think it's heating up, but we can check that in Pronterface. So I'll click over to Pronterface so you can see what's going on. And right now it looks like the temperature for the hot end is heating up. There's no bed, so we don't have to worry about that. See if I can pull this forward a little. So assembly was less than 5 minutes for this printer, which is pretty good. The rest of it, we'll find out. But this might be a good learning tool. Although I'm worried about that offset, so it might print in midair the first print. But there are little screws down here to adjust it on either corner. But let's see what happens. Let me see if I can turn up the light a little. And so it looks like out of the box it might be a little close to the bed surface. You can tighten it with these little things here to fix it, but I'm just gonna let it go. Obviously you can't see the print angle right now, but it's very quiet compared to other printers. But definitely the surface is rather close to start. So while this is going on, we'll see if we can answer some questions. So what questions you guys have today? Because this is just a little experiment I'm running. I'll make the screen bigger so you can see what's going on. The print is only 20 by 20, so it's kind of buried underneath there. I'd give you a better angle, but I have to put a second camera up to do that, and midstream it might not be a great idea. But maybe I can turn the printer. Let's see if I can lift it so you can see. Well, there's not much you can see there without me tipping it sideways. Yeah, it's horrible. So we'll just give that a moment to run away and see what we have for questions. So, what are tutorials you guys want to see that I haven't done yet? Because this might be my new experimental machine to do it. Of course, I'll have a different camera on the machine so you can see what's going on, but it's small enough to fit on the desktop and also allow me to show you the connections to the boards. Unfortunately, I'll probably have to take this shield off so you can see better in the future. But the print's, I don't want to say subpar at the moment, but that's probably because of the surface. But we're only on like the second or third layer. They're injection molded parts. Essentially the whole printer came in two pieces. So one piece clips into the other for the Z-axis. And then the motors are already built into the printer, and I believe they're NEMA 11s, but I haven't taken it apart yet to look. They somehow have them bolted in so I can't see them very well. They might even be round because I'm looking down in here. And I'm guessing that's a similar shape over here, but I can't feel it. But mostly everything's encapsulated, so it's kind of hard for me to actually break it apart mid stream. But we might break this apart, being the controller, because I think there's only 1, 2, 3, 4 screws on it, and the cabling to it goes right in here. So let's see what we got here. Should never do this at home when it's electronic and it's running. So hopefully I don't make a big mistake here and flush $80 down the toilet. Power supply is kind of hot. I think they use a laptop battery power supply. Or a laptop power supply, pardon me. So I wonder if I can disconnect this while it's printing. Looks like I can. So it almost looks like a Creality board. Looks like they have regular wiring on the inside. Let me see what you can see here. What's your question? So, let me see if I can lift this up so you can see better. Essentially, it almost looks like a Creality or something. Let's see what the brand is underneath. It's an ET4000 V2. But the wiring looks very similar. And it looks like there's ports on here for, I think that's an SWD port. There's not much else. It looks like there's a heat bed port buried in here. I don't want to move the wires around too much. But there's two ways to power it, I guess. I have to look at the board. It looks like you're going to add a second hot end or heater. So that could be a bed or that could be something else. And then there's another end stop or thermistor connection here. And then over in here you have your 4 steppers. So we might be able to easily transfer this over to another printer board and test it out in a couple minutes. Because this print that I'm doing is going oh so well. So I'm just pushing it down to see if I can get it to actually feed. I'm guessing there's a motor inside there. but already the print's failing. Something's going on with the stepper inside here. So I'm going to stop the printer for a second. Let me bring it up so you can see here. So all I'm going to do is I'm going to pause the print, raise the surface a little, and then I'm going to try and move the axis out of the way as soon as I turn back on the camera. So I'm going to try moving the x-axis because I think that's what it is. So you can see the print didn't go too well down here. It might be that it ground in the surface and then clogged the actual z-axis, which seems to wobble a lot. So I guess it is going to be just a demo printer for now. But I'll point out what we can do with this board. Hopefully I'm not going to destroy it, but let me cool things off on it real quick. So it looks like everything is off, even though it... Huh, interesting. There we go. So for some reason the button, I forgot what the functionality was. But that's going to cool down. We'll give that a moment. I'll look at questions while that's going on. Let's see. I'm new to compiling Marlin firmware and very interested to build one for my FL Sun SR. And I always get an error with the MISO pin isn't defined. That said, I want to upgrade to the SKR2 board. So let's start with the trouble compiling. Can you upload to Discord or my Discord channel your files for config.h and config.advanced.h, as well as your platform io.ini, and we'll take a look. So I'll bring up the actual chat room so you can see it here. I just have to change it over to where I am. So we have a general chat where you can post that. So give me a second here to show you on the actual desktop here. So this is Discord. The actual link is in the description of the video today. So if you go down and you look inside there, if you're looking via YouTube, you'll see in the description the link for Discord. So all you have to do is post your video right there, or not your video, your config files, and I can pull them down and show people what's going on. So does anybody else have a question or two? Yeah, it extruded some filament, but it wasn't super successful. So I'm just waiting for it to cool down to where I won't get burned on it, which looks like the temperature is 65 degrees Celsius. So this will be at room temperature and another 30 or 40 degrees. Do I have any octopus videos? Yes, lots of them. There's, I think, 4 or 5 up there right now. There's more coming. But I was going to try and start using this printer as a demo so you guys can see what's going on. But let me see what you're seeing right here. So essentially I'm going to power the system down in a second. So let's see what the temperature is at. 52 degrees. So it's probably safe to power it down. So let me take out the power. I'm going to unplug these two things for a moment. Wow, that's in there nice and tight. And then we're just going to take this apart. So I'm going to pop this out. That's for the control. It's a very simple construction. Now, things on this particular printer probably won't run as well because the motors are different. But we're going to have to figure out what all these are. So I'm going to have to crack open this little thing down here and not clip a wire by accident. There we go. So we have a wiring bundle here, a bunch of things. So we're going to pop them out one at a time. Let's figure out what they are first. So E is extruder. So it's a white connector. So I'm going to pop this out, hopefully without breaking it. And I'm going to put an E on it just in case. So let me find a pen to do this. This way I know what's going on with my hardware, hopefully. So it's got an E now. Next one is probably Z. Yep. So I'm going to have to put a Z on that. Hopefully it doesn't look like a 2. Now we've got our Y-axis. The reason I like to label stuff is so that I don't get super confused later on. And then we have our X-axis right here. So let me grab a different color pen. Okay. So we've got that disconnected. Now we've got 3 end stops probably. Notice how they have 2 wires. So one wire is voltage, one is ground. The voltage is probably not red, so it might be signal and ground. But we'll take these out one at a time and mark them. So that axis is the X-axis. So we'll mark that with an X. Next one we'll pull out is the Y-axis. Now we'll do the Z-axis. So we're good there. Now what do we have left on the other side? Hopefully I'm not screwing these up too much. So we have voltage and a fan. So they might be 2 12-volt fans. So I'm going to pull one out and just pull the other out, and we can sort that out in a second. There's the actual power cables, and I'm guessing that is probably for the hot end. So let me get a flathead screwdriver and take it out. Okay, notice how they didn't do the safety with ferrule connectors. Granted, it's a child's product, so it should be safe. Here's the thermistor, so I'm going to put a T1 on this, being that it's thermistor 1. So I do my 1s backwards, apparently. So I think we've cleaned out everything on the board. So there is a connection for flashing it here or your media files. You got your USB serial. And then you have your power. Looks like what else they have on the board that might be of interest are a second thermistor right here, being the heater part and the actual temperature sensor part. So I don't think those are going to be very useful. They have surface mounted steppers. I'm guessing they're something like a TMC, or excuse me, something like a A4988, but that's just a guess. So let's take that out of the way and put a board down and try out moving stuff. Now, we're just going to do something with the Octopi. So let me see if I can get that in here. I got to clean up some of this mess. We're going to start with end stops just for safety and hopefully not blow up our board. So that's the other thing I got to do, is look at the board and see what the end stops look like. So let me see if I can zoom in on this. Let's see if we can move this over a little. And I might have to turn out one of the lights so you can see. There we go. So this board, we're going to look at the end stops. I know they're probably a little blurry for you, so let me see if I can focus it a little. Well, I can't pick out much from what you're seeing, so I got to pick it up and look. So my guess is the bottom pin is signal, then it's ground, then it's voltage. That's my guess. If I take the board out and look at the bottom, I might know. Now this is obviously an unknown board to me, so without an actual data sheet, I'm not going to know much. But it looks like there's only 2 screws holding it in. So we'll lift it out and look. So sure enough, if we flip it over and we look on the bottom, there's signal, ground, voltage. So now we know what those are. So in this case, if we put our finger here and flip it over, voltage is right here. So they're doing signal and ground for the way that they're running it. So now we know how to do it with the actual board, which I'll grab right now. I'm going to grab a cheap board to start. Sorry, I'm just trying to grab something that's not too expensive in case I make a mistake. Well, let's do it on the ramps. So this is the ramps board. Talked about it a long time ago. We have end stops on this. We have our X minimum, our Y, our X max, our Y minimum, our Y max, our Z minimum, and our Z max. And then they have written on the board signal, ground, voltage. I know it's kind of hard to see right now, and I got to look at the board, and sure enough, that's what it is. So I'm going to hook up one of these end stops as soon as I find one. We know they're 3 pins. And what we need to do is have the red wire on the right side so that we match it to the signal. And then slide it in. Hopefully it fits. Otherwise I got to change the connector. So that looks like it fits. So we're going to power it up and connect to it. So there is firmware already loaded on here. Let me stop this sliding around for you. And we're just going to figure out what's going on with the end stop. Now the end stop is the X-axis. So that is located on this printer up here, right there. Let me see if I can slide this into frame better. So the end stop is right here, where I'm clicking. I don't know if I can make the angle better. There we go. So what I'm going to do is I'm going to bring up printer face. And obviously I can't connect in printer face just yet, so I need to bring up device manager and see what the connections are. So inside device manager, I'm going to go to ports. It's the Adreno is on 8. The speed's probably 250,000 bits per second, and I'll check on the chat in a sec. So we're connected, so let me bring up the workbench with that. So now that we're connected, we're going to check the status of the end stop. So M119, enter. Everything says triggered. Now I'm going to hold down the trigger and try it again. And it still says triggered. So I might have hooked up something incorrectly, or it's the wrong end stop. So let me check the other two. That says Z. And this one says X. So this must be Y. Yeah, that's my funky Y. So let's try that again. So the Y is someplace around one of these places. Now I gotta find it. There it is. It's right here. So I'm gonna click that and I'm gonna do M119 again. So apparently I'm connected to the Y-axis with the end stop, but it works. So we know how that works. Let me go back and check on the chat real quick here. So let's see, do you have any vids on the Big Tree Tech Octopus? Yeah, they're in my playlist for Big Tree Tech Octopus. I know I actually answered that a second ago. So I'm looking inside Discord for any uploads. I don't see any at the moment, but I may have gotten a notification someplace else. But I don't see them yet, so I'm guessing he's trying to post them as we speak. But we'll see about that in a few minutes. So while that's going on, I guess what we'll do is, now that we know that it's voltage for red, or excuse me, signal for red, black is ground, we'll take a more expensive board to it. And we'll try some steppers. Now the steppers are not going to be real successful. And the reason being is the steppers that we're going to use probably are going to be a little bit strong for these actual motors. So we're going to crank them down power-wise. Now I don't know exactly what motor they have, so that's going to make it interesting. So I'm going to take out the SKR board. And we're going to start with, let's see, a TMC 2208. Let me just make sure I have one here. Okay, that looks like one. Let me make the video bigger so you can see. Yeah, sometimes I don't think it is either, Ron. So, on the workbench, I've got a stepper. It's TMC 2208, and we have to configure it correctly, which I already have the jumper in the right place. And with these steppers by Big Tree Tech, it's kind of simple. So you just line up the colors and plug it in. Now we need to find the X axis. So there's the E. Let's see if we can unbundle this a little here. There it is. No, that's the end step. That's the Y axis. That's the Z axis. So where are they hiding? There's the extruder. I'm trying to get the right axis here, so those are the end steps. That's the thermistor. So that's the end step again. So here it is. So it's a notched connector. So I'm going to slide it in like so. Then I got to clean up a little so I can do this power-wise. So right now it's on direct power from USB. We're actually going to use the power from the board. So I'm going to move this over to the correct jumper position. There we go. So now it won't power the board. Now I need power from a power supply unit. So I've marked these red for voltage, black for ground. The actual power for this board is right here. So I'm going to slide that in. Notice how I'm using ferrule connectors for safety. I'm going to tighten that down. Then I'm going to do the voltage over here and tighten it down. Hopefully you can see what I'm doing after I get my hands out of the way. And I'll make it so the board doesn't move around on us. So this board is the SKR 1.4 Turbo. So now that we've got that connected, I'm not going to power it just yet. We're going to see what we can do to set up the actual configuration. But I need to connect the actual end stop, the correct one in this case. So that looks like it's the X that I rubbed off with my finger, or it's the Y. So let's check the other two. So that's Z. And that I hope is Y because I've rubbed it off with my finger. So it's voltage on top in this case, then it goes ground signal, but we'll double check before we power anything up. So that's all we care about at the moment. I'm going to go over to VS Code as soon as I remember to open it. This also walk through some people that want to see the compile. So I got a couple things I need to do real quick to show you this. First things first, I need to close my previous edit. Then I need to go over to my downloads folder, enlarge it a little, and I need to get rid of the Marlin that I unzipped, and then extract a fresh copy. So I'm going to extract all, and we'll check on the website real quick to see what's going on with Marlin in a second. Let me just bring it up. So here's the Marlin main page. We're going to go to downloads. Looks like the build hasn't changed since the last time, so we're good there. The extraction's almost done. So I'm going to bring up VS Code in a second. Of course, I've got to make sure that it's working for me to see it. Two seconds here. I just have to make sure that I'm on the right thing for this. There we go. So inside here, there's a button called Explorer. So I'll show you that in the browser real quick. Or the desktop, pardon me. So I'm going to open a file here. Open folder. I'm going to map to my Downloads folder, Marlin folder, Select folder. Now I'll go back to a better view for you guys. So inside here, right now it's default to a mega board. We're actually using the SKR version 1.4 Turbo. So we need to go to Marlin source core boards.h, search on SKR. And this is not the one we're currently using. It's a slower one than this one down here. So I'm going to highlight the actual board type, copy, minimize core source, go to configuration.h, search on motherboard, paste it over what the ramps was. Then I'm going to go back up to serial port and change the 0 to a -1. And that'll allow us to connect to the board later on. So I'm going to power this up in a second, but I want to configure a couple of things such as the steppers. So I'm going to search on the A4988, which is not the stepper we're using, and search for the TMC2208. I'm going to paste it here. So we're good there. Now I'm not going to adjust the actual default access steps per unit today, but I do need to adjust something in here because I'm not sure what I'm working with. Normally I would need a data sheet, but I'm going to make an educated guess. So I'm going to search on 800. This will bring us to the setting for the stepper. I'm going to change the current down to, we'll try 200 to start and see what happens with that. Hopefully there won't be any smoke. And that's about it for configuration, except for the actual TMC debug. So there's two places we got to turn this on. There's monitor driver status, and then there's a second one down here, which is TMC debug. And that allows us to use the debug code M122 to check the status. So once we've got that complete, we're going to go over to our platform.io.ini and set up our default environment. And that's based off of source core boards.h. We grabbed it from down here. So what that means is that it's the LPC 1769 in this case. The other way you can verify this is to go to the INI, look for LPC 176X, and what you see right here is the two board types. We've already got this one that we just copied out of boards.h, but this is where it's actually defined, and each one of your boards will be defined that way. So let's go back to platform.io.ini. Highlight the Mega 2560 and paste. And then what we're going to do is we're going to do a build initially just to see if it works. And I'll look at the chat while that's going on. I try and go live every Friday. So the build didn't go well. So what happened? So I need to scroll back here and look. So .pio. So in this case, I'm going to try and build a second time and see if it works. Sometimes it fails on the first try because something builds out of order. And so this is one way to get around the problem, is build the second time. So let's see. And can you please make a general video on what screens are compatible with the SKR2 and how to adopt the MKS screen or Creality one to the SKR2 Marlin? I know for a fact that some hardware modification is required. Yeah, it might be moving pins around in the actual pinout file, and I'll show you where that is real quick. So what he's asking is, with his board, how to change the pins. So in order to do this, we need to know a board type. So I like to go to Source Core Boards and search on SKR2, and that doesn't come up, so _2, and that's still not coming up. So let's see what we got here. I know there's an SKR2 in here someplace, I hope. It might be V2. There we go. So the only version you want to use is this one, but it's an STM chipset. So there's a couple of clues on what to do. So STM, then you want to look for the STM32F407. So I'm going to minimize this for a second. I'm going to go to the INI folder, look for STM32F4, which is right here, and I'm going to search on it just to see what it is. And the reason I'm doing this is not for the Big Tree Tech 2, so I don't see it right away. So I'm going to scroll down through and look. I'll show you why this is important, just so you can locate it. So I might be in the wrong folder on this particular board, but nope, there it is. So they named it slightly different. So the actual place I want to go look for this, though, is in Source Pins, STM32F, and then inside here is probably the board for the pinout files. So we have to scan through here and find SKR Big Tree Tech version 2 Rev B, and that tells us to go to the common, which is right here, and these are our pins file. So this pins file allow you to set up your actual display. It's down here someplace at the bottom. So let's see if we can find it real quick. So there's your pins. So if you can find the pinouts and match them up to the actual pins on your LCD, that's how you would set it up. And then you'd realign them down here with what your pins are. So essentially it's just match the pins. But let's go back to what we were working on here. So inside here, we can check to see if the build finished, which it did, and it was successful. So I'm going to power up the board and hopefully see no sparks. So let's see if I can find the power supply real quick. The correct one, that is. Okay. So this is what I'm about to do. It may be kind of dangerous because you never know with these types of boards. Is I'm just going to power up the power supply. So nothing happened. It's just beeped, so it's connected to the computer now. So I can go back to VS Code. And now I can just do an upload directly to the board, hopefully. But we'll check that in a second. Okay, that's complete. So let's go over to the desktop of the computer and check it. So inside here, we're going to go to the D drive, and we just loaded the firmware.bin. So we got to power cycle the printer to load it. So let's go back over to the workbench. I'm going to pull the power. Now I'm going to plug it back in. Now it's back online. So let's go over to printer face. And inside printer face, we don't know what to connect to, so we need to figure that out. So we're going to go to the device manager, and the COM port is 7 in this case. So we'll close out of there. We'll change the 8 to a 7. We'll connect. says printer is now online. So let's check the stepper with the G code M122, enter. So it says it's okay. So I moved the actual axis to the center. So I'll show you what's going on there. So on here, if we can see it, it's kind of in the center of the axis. So I'm going to try and move it just a little and see if it's okay. We don't want to move by 10 because we didn't adjust the actual surface size. So we're going to move by 1. So apparently it's not moving very well. It's trying. I can feel it grinding with my finger. So that means we might have the actual power too low. So let's go back over to VS Code. And inside VS Code, we'll go to configuration.h. We'll search back on 800 or scroll up a little. It's right here. We're going to change this to 400. And then we're going to reload this again with the right arrow. And I'll check on the chat while that's going on. Okay, no new questions just yet. And the other thing we're going to do that I forgot to do was change the configuration for bed size. So let's search on bed_size. And what you can see here is the bed size for the printer is 200. It should be 100 and 100. So let's do another build. And we're not worried about max Y for the or max Z for the moment. So we'll take care of that in a second. So that just popped. So let's check to see what that looks like. So go over to the D drive. It's got a new firmware on it that just popped in there a few seconds ago. So we're going to minimize that. And we'll go back over to the workbench. And I'm going to power down the board. Then I'm going to power it back up again. And then I'm going to go back over to Pronterface. Inside Pronterface, I'm going to disconnect and reconnect. It says it's online. Let's check the actual steppers. So we're at 400. So I'm going to do a movement again and see what happens of 1. I'm going to stick my finger on here so I can feel it. This is just on the rubber band. So it feels like it's moving. So I'm going to try 10. So it is working now. So I'm approximately at the right power level. But because this is a actual stepper, I'm unaware of which power requirements are used in it. I'd probably have to pull up the data sheet in order to figure out exactly where I'm supposed to set it. But this is a good estimate. Unless I start to feel heat here, then it's probably crank it down. And then there are debugs that you can use to control the actual settings inside Pronterface. So we've got one axis working, so let's try homing. Now I got to keep my hand on the power in case this goes away from the actual end stop, which is located right here. But let's make sure we have an end stop first. So we'll go to M119, press enter. Currently it says everything is triggered, which is bad for us. So we're going to click down and do M119 again. And it says open. So it needs to say open instead of triggered, so we'll fix that as well. But I'm going to try and home it and then pull the power if an issue occurs where it's going the wrong direction. So I'm going to go over here and press home. And apparently it doesn't want to home. Let's try that again. So it's moving the opposite direction. So that's good. We don't have to worry about that at the moment. So I'm going to power it down just for the moment. Then I'm going to power it back up. That's in case it's trying to process the commands. I'm going to go over to VS Code and we're going to make these mods real quick. So inside VS Code, I've already set the bed size. I'm going to scroll up to the top here. I'm going to search on invert. So we have mechanical end stops. In this case we have X minimum. So it was coming up triggered when it should say open. So we're going to say, instead of false, we're going to say true. That should fix that. The direction for the actual stepper was inverted, so we have to search on invert again. So it's going to be a couple of searches. So we have, let's see, inverting stepper enable pins. That's not what we're looking for. Let's see, disable access. That's not what we're looking for. But down here, where it says invert X dir, so we're going to say true. That'll cause it to go towards the end stop when we press home. So let's upload that real quick. And I'll check on questions real quick. Okay, there's no questions just yet. Let me turn the camera back on because it just clicked off. So now this is built. Let's double check to make sure that it's actually uploaded. So inside the file for here, we have firmware.bin again. So we got to go back over and disconnect the actual power. So I powered it down. Now I'm going to power it back up again. And we're going to see if this actually works. So let me see if I can move this forward a little. Yeah, so the end stop's right here, so we'll test that real quick. So if I go over to Pronterface and I connect again, I'll do an M119 to check the status. It says open. I'm going to trigger it with my finger and do it again. Now it says triggered. That's good. Let's try homing it. Now it's really going the wrong way. So now I got to pull the power. If it didn't fail already, which it did. So the issue there is there's something going on with possibly the motor. So what we need to do is first invert back to the other direction. So I'm going to go over to VS Code. This process with printers can be somewhat iterative, meaning you're going to have to do this multiple times. So I'm going to hit Control Z to undo this. And then I'm just going to upload again. And while that's going on, I'm going to center the x-axis. So let's see what's going on in the chat. Let's see, I tried multiple times to join, but no luck. It takes me to Discord website and tells me to download it and try the search Discord. And can't find it. Welp. Okay, so essentially I think the name may have changed. So let me see if I can see it real quick here. Inside Discord, it's called Adds 3D Printer Tutorials. So search on this. And see if you can see it in there. Apparently when I changed the name, it may have changed the actual links. So let's go back over to the actual printer and try this again. So I'm going to power it down so I can load the firmware. I'm going to power it back up. I'm going to connect to it. I'm going to check the end stop just because. That looks good. Now I'm going to do 1, 2, 2. That looks good. Let's try homing real quick. So it might fail. So the next issue is that it's something to do with home. And I think that might have to do with the power or the speed. So we can change that, but I'm going to change the power first. But there's something causing that failure. And I probably won't be able to figure that out tonight. But let's see what we've got. Printer halted. So what we're going to do is give it another try here. So I'm going to go back over to VS Code. I'm going to go to the advanced configuration. I'm going to crank this up to, we'll say 600. This might be a little bit high. And then I'm going to upload it to the printer. But this may fail because the printer board stopped, but we'll see if it works. Okay, it may have worked, so let's see what's going on. So if we go over to the D drive, we have no D drive. That's awesome. So we've got to power cycle it because it failed. And plug it back in. Check to see if we have D drive, which we do, and try and upload again. These are just common things that happen. So let's go back over and look. And now it has firmware.bin. So let's go back over to the desktop. Power down the board. Power it back up. I'm going to move this over a little. And then we're going to reconnect again in Pronterface. So inside Pronterface, disconnect, reconnect. It says we're online. Let's check the status. Seems to be a little bit high, but we'll try the home real quick. This might cause smoke. So there's still a failure. So what we can try next to get an idea of what the failure is first power down the system. Then inside Pronterface, we'll go to Settings, Debug Communication. So let me see if I can clean this screen off. Now let's see if there's another way to do it here. Clear console. There we go. I'm going to plug it back in. I'm going to disconnect, reconnect, and I'm going to try and home again. This might be real close to homing, so it might work. So it failed, and we didn't see anything except that homing failed. So there's usually more debug that you see. So let's make sure I got everything on here. So it looks like I have debug communications already set. So that's not going to give us much information apparently. So the next place is for me to start searching forums. But let me see if I can answer some of your questions while this is going on. Let's see. The screen was stuck at VS Code. Couldn't see the name or the link though. Are you trying to get to my Discord page? Or are you trying to describe the problem? Let's see, after 9 years of having given up on the FFF/FDM, I think he's talking about different types of printer filaments or printing ways. And I really hope the price for a 200 by 200 bed size resin printer can seriously come down. $2,000 is too steep for me, plus the cost of the resin. I totally understand the costs can be painful. Obviously I don't talk about resin a lot because it costs a lot. Another issue is the need to replace the projector. Too many costs. So I guess he's talking about a resin printer. But how's it going, the best stooge? For those who don't know that, there's something called the Three Stooges. There's actually, I think, 4 of them, but there might be more. There's Mo, Larry, Curly, and Shemp. But that's slapstick comedy, so if you don't know what it's about, you might want to watch it. Let's see. No. Trying to get to the page. Okay, so you're trying to get to the Discord page. So is anybody in the chat able to give him the link to Discord? I can't seem to pull mine up right away. I fumble and bumble on this. But let me see if I can pull up the page so you can see it. Okay, so here's the Discord page. That's the link, I believe. So if you have a Discord, I can send you an invite. Obviously, I'm not going to show you a lot of the settings here, but I can send you an invite if you post what your Discord name is in Discord. I can try and invite you this way. So if he left for a moment, I'm not sure if you're still there. Let me know, but you can leave a comment in and I'll try and invite you through the Discord channel and pull you in that way so that you can see the general chat. But I'm going to end this now that we're about an hour and a half into it. And remember, you can always post questions or requests for tutorials down in Discord. You can share your designs now. There's a BL Touch room, a print quality room. There's the Big Tree Tech TFT display as a room to chat. There's a general chat, and then there's YouTube requests. A lot of people post what they want to see for YouTube videos in here. And I got to scroll down so I can see what's going on here. No, trying to get to the page. Is this that you're posting in there, your name being... So I'm guessing it's without the 576. Hang on a second. Let me see if I can set that up. And I just had it a second ago. Let's see, general. Invite. Well, let's try this. So I'm going to post this in the chat and see what goes on for the stream. Try this address right here, because apparently I forgot about that. So they may have changed the invite to expire in 7 days. That could make things slightly painful, but I'll see if I can make that so it can stay up longer. But that should get you to Discord in theory, the link that I just posted. But for those of you that have been tipping while I haven't been paying attention, thank you very much. And those that do super chats, thank you very much. And everybody, remember to get vaccinated and take care and be safe. And I'll catch up with you next Friday with the questions that you post.